folks. Let's get started this beautiful Wednesday morning. Okay, so first thing I want to talk about is scary thing. The final. Actually, I don't like this. Let's zoom in. Okay. Who likes taking finals and exams? Who likes grading finals and exams? Watch out, he's my TA in my other class, so I think he's buttering me up. So I raised his hand, he definitely likes grading finals. Alright, so here's what we're thinking. I want to get your feedback. Instead of having a final exam, we'll do a final, CTF, a capture the flag. So the idea will be, so for those that don't know, a capture the flag is basically every team that participates is going to have their own system, right? You each have some Linux machine. Every system is running the same number of services, like a website and some custom software that we've written, right? And the important thing is everybody's running the exact same copies, right? And so the idea is what your team has to do is to hack into everyone else, find the vulnerabilities in the services, exploit those vulnerabilities in order to steal a flag, which proves that you actually broke this service and this vulnerability. So there's a central system, I think we call it the score bot, who is continually going and setting flags every X minutes, like 2 minutes, 5 minutes, whatever. Then this way, let's see if I can draw a little flag. Yes. It's a pretty good flag, right? A little longer, right? So your team, yay. So you exploit this system, you steal this flag, right? And then you submit it to the scoring system, right? Which says, oh hey, this is the flag for team not leaked. Right? This is the flag for team not leaked. That means you must, in order to get this flag, you must have broken this service, right? This service, let's say web, is the only one who can access this flag, which means that if you broke this service, if you have this flag, this means that you broke this service, right? And so I can give you points for it. So at the end of it, so there'll be a scoreboard, which will show all the teams and their score, right? And the score is based on, how do you spell? With spell check. It's not harder with handwriting, I'm finding. Right? And so we will set this up so that we can play a CTF during the final. So some of the things this will require, a laptop or a computer. If you do not have one, so let's talk about teams. So I'm thinking max 6 people, because otherwise there's too many people. It's an unfair advantage of having too many people. So maximum 6 people, no minimum. If you want, 0 would be a minimum, right? It doesn't make sense.
Does that mean we can register a team with no participants?
No. So minimum 1, we'll say. You can't deny the service, the infrastructure, right? So maximum 6 people, a minimum of 1 person. You can create your own teams, do whatever you want. One thing that I would maybe suggest is you're all working on different projects, right? Different kinds of defenses or offensive tools for different types of vulnerabilities. So if you try to diversify your team so that people are experts in different types of vulnerabilities, you're going to improve your chances of doing well. And the other thing is on your server, right, you can actually apply whatever defenses. You will have root on this server, so you can do whatever defensive techniques you want to do, which include using your projects, right, on the final CTF to protect your system, or to help you exploit, if there's a format string vulnerability, to help you exploit that. So that's the high level idea. What do you think? Thoughts? Yeah.
Would you like the assignments for the time, like for 2 hours?
Yes. Yes. assignment 3, except you all are trying to hack each other, not one central thing.
Would there be, for example, like Thursday from 4 to 6, or will it be out for like a week or something?
Do you want to do it for a week? No, we'll do the day of the final for the final time. I'll also leave it open for a while so you guys can still play with it. That I'm totally fine with. Yeah, but at least we'll do it day of, because I don't know, do you want to do, we could do like an 8-hour thing. I feel like it's jerk, because I think our final is on Monday of finals week, so that's a little bit of much to ask of teams, right?
It normally is like 6 or 8 hours.
Yeah, a normal CTF is anywhere from 8 is usually the minimum, 8 to like 48 hours. And that gets crazy, you have to like sync up sleep schedules. And actually the best thing to do is get people in different time zones, so you're constantly working on problems. But yeah, we'll just schedule it just for the time. And I'll try to, this makes it tricky, I have to adjust the challenges and the services such that they're doable within that time frame, right? Yeah. Other questions? Yeah. You already asked one.
Would it be just web apps or binary?
Both.
And
It'll be
networks?
both. Yeah, so you gotta think you have to access these through a network, right? So everything will be networked. There will be either binary applications, which are networked, or web applications, which obviously are networked, right? So it'll be a mix of both, right? So that way it gives you incentive to prepare your web skills, since we don't have a final on that. Yeah.
Spoofing attacks or?
They won't be possible.
Spoofing.
No, it won't be possible. No, because I'm creating this network, so I will make sure that none of that nonsense. Hopefully none of the nonsense I taught you can be used. If you find other nonsense that can be used, you should let me know.
So you are allowed to use all the open source tools?
Yeah, anything you want. You can install whatever you want on the systems. I'll try to give you access like at least a day or two before the actual final CTF so that you can go in and configure things on your server. But you won't know the services that are running yet, right, until the day of, because that's kind of the puzzle. We don't want to release those early. Yeah.
So will we have to determine what those services are, or will we have some kind of list, or?
It will be in a standard format. So yeah, I'll probably work with Sai to get like a list of things that you do and things that you need to know, right? Once you get on the box, where are the services? How do I restart services, right? If I want to patch them or something. What are these other services? Like what are the whole IP range of all the other teams, right? What are the ports of the services? Those kind of things. Yeah.
I assume you'll be pulling the systems to make sure the services are still alive on our boxes.
Why would I do that?
Because we could just lock it out with IP tables so that they can come in.
Right, yeah, right. So one defensive strategy is, well, if you don't want anybody to hack you, you just shut down all your services, right? So like perfect defensive score. But that's super lame, right? Because, well, then it defeats the purpose of the game, right? That's like, if you think about game theory, well, it's in everybody's best interest to shut down their services, and so everybody shuts them down, and so nobody can play, right? So continuously, yes, there will be a system that is constantly interacting with each of the services. So this actually goes back to patching, right? You can't just patch something by like wiping out all of the functionality of your application, right? The application still needs to function, you just need to patch that vulnerability. So yes, periodically, the score bot will be actually checking each of these services, and we do it in such a way that you can't distinguish who it's coming from, right? Because we're the game network. I can actually make it appear as if I'm coming from one of the other teams, but really it's me. Yeah.
Will we know how many people have violated our services?
Maybe. It depends on how much work I want to do on the scoreboard. So by default, let's say no, but maybe as time goes on. Right, but you do have root on here. You can TCP dump and see the traffic that's going on, so you can see what's happening to your system. Maybe you can identify somebody else's exploit to reverse engineer it or to use it against them. Yeah.
Do we have some kind of just example of how it all, kind of how it works, you know?
Yeah, my hope is, I'm hoping at least, well, let's say by next Wednesday, because that's at least a little less than a week beforehand. I do want to give you access to like a mini test network that hopefully we can do like a practice run with. So depending how we do on content, because I want to make sure we get through cross-site scripting and SQL injection. Depending on how we do, maybe next Friday, like the last class, we'll do an in-class practice run of the CTF with like dummy services, or maybe project assignment 3 services, so that way you already kind of know how to exploit them. Yeah, that way we can get familiar with getting on there, because you have to worry about SSHing into there, and port forwarding and copying things, so. Cool. Any other questions? So should we give this up? Do you want to go back to an exam? No? Okay. Cool. Yeah.
Unrelated. Do you know what the average was on the midterm? Sorry.
Unrelated?
Well, you said.
I don't know it off the top of my head, no. I have to look that up. Cool. All right. Then let's get started. All right, I'll send out more details too, so we can make sure we do this. So, yeah, let's aim for teams by, let's say, a week from now, like next Wednesday. I want to know all the teams, so I will announce how to tell us that, so I don't get like tons of emails. Yeah, so self-organize, find teammates, all that kind of good stuff. Or don't, if that's your style. All right, maybe I'll use this diagram. The official webpage. Okay, so we talked about SQL injection vulnerabilities. So what is at the core of a SQL injection vulnerability? What does it allow, and what fundamentally can attack? What's the cause?
User input?
The cause is user input. In what way? Is every user input?
No, not every.
What causes user input to
Something that makes the statement
what statement?
the query that you're making to the server.
Right, yeah, so being able to, essentially, right, the fundamental problem is an attacker can alter the SQL query that we're making to our server, right, the SQL server, right? That's fundamentally the problem. If it was not possible for an attacker to alter the query, then it wouldn't be, there is no SQL injection vulnerability. So, how do we identify these? How can we identify SQL injection vulnerabilities? Right? What do we look for in, let's say, buffer overflows? How do we identify buffer overflow vulnerabilities?
By looking at the variables.
By looking at, what about the variables?
If they're extending the input is extending the buffer size.
Right, so if variables were used, if some of our input was used to copy into another buffer and the length, either the length we could control or the length was unbounded. What about without looking at the source? How could you figure out a buffer overflow vulnerability without looking at the source? Yeah.
Segfault.
Segfault, yeah, you just try giving it a bunch of, all the ways it gets input, just try throwing a bunch of input into there, right? So those are two different ways. What's the two different ways there? What do we have and what do we, like? Right, so one way we're looking at the source code to find the vulnerability, or even looking at the assembly code if we're super elite, right, to try to find the vulnerability. What about the third one? Or so what about the other way? What about just throwing, do we look at the source code there? Right, so often, so in web applications, can we identify the source code of the web application?
Not complete.
Yeah, not completely, and oftentimes not always, right? It could be, I mean, just, this is actually how the web works, right? We make a request, something happens, and it spits back an HTML page. We don't know what code ran to execute that request, right? It could have been anything. So how can we, so in the web, we're actually interested more in how do we identify vulnerabilities without knowing, without being able to access the source code, right? Yeah.
So if you send in certain information, certain data to web pages and you get an internal server error, would that be?
Yeah, that could be one, right? That would be the analogy to the segfault, right? Is you send some data and you are looking for a server error, right? And but then specifically, so that's kind of the general way of how to do it, but specifically, how do I do that for SQL injection vulnerabilities? Yeah.
Put in a tick mark, it'll query.
Put in a tick mark and it'll do what?
It'll end the query that's executing if it's vulnerable, and oftentimes it keeps back the SQL error.
Yeah, so by putting in a single tick, right? We now are generating we are now generating a invalid SQL query. Guys. Nice. Okay. So by inputting a tick, so basically one of the ways is we want to try to trigger a fault, right? And so we can do that by basically making the SQL query be invalid, right? So this is kind of what we can consider as a negative approach, a negative in the sense that we're trying to get the program to fail, right? If the program fails when we pass in like a single tick, then we know that there must be something wrong with this program, right? It is probably using this in a query and something went wrong. If we're really lucky, we'll actually get the SQL error message that says, hey, there was an error in your query, there was an extra tick here. If we're not lucky, we may just get a 500 error that says, hey, something bad happened, right? But here, I can try, hey, if I pass in, Adam for a user, and I don't have a vulnerability, and I get back a 200, but I pass back a tick, and I get a 500, then that means there must have been some kind of, there's probably a SQL injection vulnerability somewhere. So what would be the opposite? What would be like a positive approach?
Passing and 1 equal to 1.
And 1 equals to 1. So yeah, why would that be a positive approach?
I do not know whether it's a positive or negative, but it will help whether SQL injection is possible.
So let's think about it this way. Will it cause the query to fail?
Yes.
No.
I mean,
Or, sorry, that's a good point. Will it cause an invalid query to be issued?
yes.
And 1 is equal to 1? Well, you may have to add comments maybe too. And that depends on the tick, right? We may want tick and 1 equals to 1. So you're saying we want the result to fail, like it will return 0 rows instead of however many rows before, but the query is still a valid SQL query, right? Exactly, yeah.
What if we give and 1 equals to 2, so it's getting false, and like we know that the username equals to a valid username and 1 equals to 2.
Yeah.
So if that gets failed, then we can know that the post part is working fine. So
But how do we know it's actually a username, right? We may not know what it's actually testing for, right? I mean, because it could concatenate things, right? We may not know, but yeah, that's the general idea. Is the other way, for one example, right? Let's say we just search for something with an ID, like select star from users where ID is a parameter, right? So if I pass in 17 plus 5, right, that should return no users if it was properly escaped, right? So it's going to look for a user with the ID of 17 plus 5. But if it's not escaped, right, then it's going to return me the user who has ID of 22, because SQL will do that addition for me, right? So yeah, so the idea is you're trying to find different behavior from the system, but not one that says, hey, this is a SQL query, this is an error SQL query, but something that actually shows that the SQL server is processing your results. Okay. So we saw kind of how we can maybe use the tick or 1 equals to 1 to bypass maybe some login mechanisms, right? Essentially there we can make any query true, right? But how do we actually get data back, right? We want to be able to extract data from the server, from the database, right? I told you I kind of sold SQL injection vulnerabilities as the promise of you can download the entire database, you can get all the information from the database, right? But if we're just setting a query to be true, how do we actually do that? So the idea comes in with the union operator. So anybody who's very familiar with databases want to tell us what the union operator is used for? Sorry, not your head. Do you want to answer?
Combine different
Combine what?
multiple queries.
Yeah, to combine multiple queries into the same result, right? So we can do so the idea is the union operator merges the results of 2 separate queries. So we can say, hey, select ID from, well, that's not a good example. Coming up with database example on the fly is apparently not my forte. So here I'm selecting, so repeat one, A1 is a SQL function that will just repeat will repeat A once. So this will return A, union select repeat B 10 times. So the result is going to be A and it should be 10 Bs, right? And it's going to return all of those A's and B's as if it was one query that selected the A's and the B's, right? And the very important thing here is that the queries don't have to have, well, they have to have very few relations with each other, right? So I can select from users and I can union that with a select from customers and union that with a select from the product table. And so we can actually use this, right? So oftentimes we're going to be inside a select statement where we can alter the SQL query. And remember, the important thing is wherever we can inject, we can't change anything that happens before it, right? We can only change the query and what happens after that query. So if the original query is something like this, like select ID, name, and price from products where brand is equal to tick B, right? This is easily something that developers write and do literally all the time. Yeah, honestly, if you can do like GitHub searches for something like select and then a wildcard where something equals $ like underscore get, like to look for who's using get global variables inside these strings, you'll find a lot of stuff because everything is terrible. Right? So here, do I really care? So here, right, if I do tick or 1 is equal to 1 dash dash, what's this query going to return?
It's going to return a blank row with the
Going to return a blank row?
you're just going to give tick, right? So
Tick or 1 equals 1 dash dash. Yeah, it's going to return everything, right? It will return every product in my database, right? Which is good, right? I mean, that could be information that we want as attackers, right? But do we really care about the products? I mean, we could just scrape their web page and view all their products anyways, right? What do we care about? Users, credit cards. Yeah, we want to get other information from the database that we shouldn't really have access to. So our goal is we want to add a union clause after here that unions with other things from other tables. So we can union this with a select, let's say, username, ID, username, password from users. And then it will first fetch all the products from the product table. Then it will fetch all the users from the user table, concatenate those results together, and return it all. And it will show us whatever this is being used in the web output. Like let's say this gives us a list of products. It actually gives us the list of products and also new products that look as if they're users. Yeah.
You could also use the master tables. So like you can query what all the tables are in the database typically. With like
Yes.
MySQL and
Yes. I think that's a database dependent technique if I recall
it
correctly.
changes database to database, but
Yes.
they don't all have it. I mean, from Oracle to MySQL to SQLite.
Right, so yeah, so you can use this, I mean, so if you already know the tables that you want to get to, you can use this.
Yeah.
But yeah, you can also use meta information that the database has to query those to say what database do you have, what tables do they have, what are the schemas of those tables, right? So we can actually include that in here. So the idea is here, if we modify this query, if we pass in as B, foo tick union something, right, then it becomes select ID name price from products where brand is equal to foo, union, select user pass null from accounts dash dash. So why did I pass in null as a third parameter here? Yeah.
They both have to have the same amount of.
Yes, so when I said that the select queries are distinct, right, they're distinct except that they must return the same number of columns, right? So this is saying, so basically this has to say we need 3 columns, right? We need a user, a pass, and or here it means ID, name, price, but here we're saying the 3 columns are user, pass, and null. And so, okay, does this mean that now we're kind of screwed? We have to know exactly the structure of the query parameters? Kind of have your hand half raised there.
Just that I think also they have to match type.
Yes, so that's the other thing. So the types actually have to be the same, right? Or I think it depends on the database system actually. So yeah, the types need to be the same. Like you may not be able to use an int where you're using a string. The nice thing about the null is that the null is type compatible with everything, right? So we can use null here. And so, yeah, so here we would have to know, so there's two problems here, right? We need to know beforehand the structure of the query. What does the query look like? And we need to know the name of some table we want and the columns, right? But we don't know this from the outside, right? All we know is we found a SQL injection vulnerability. We're relatively confident that it's being used in a select, right? In this select statement. We changed the brand. We passed in a tick for the brand and we saw it crash, right? And then we passed maybe tick space or 1 is equal to 1 dash dash, and that caused it to return all of the products. So now we know we're good. Now we know we're injecting into a select statement. But now we want to use a union, right? So then do we have to break into their website to read their source code to find out exactly what that query is? No, although, you know, we probably, SQL injection vulnerabilities wouldn't be as cool if we had to do that, right? So here we have other ways. So the idea is we want to be able to determine A, the number, and B, the type of the select parameters, right, in the SQL query, or the columns, the number and type of the columns, right? The idea is we can actually use this idea of testing for when things crash, right? So first we can do union select null, right? This query will fail. It will throw an error if this query, if the original select statement only has, or has more than one column, right? But it will be true if it has, it will succeed if there's one column, right? And we can just keep doing this until we finally get something that works, right? And it's not gonna be, I mean, that could be like 20 or whatever. You're a programmer, you can script this, right? You don't have to do this one at a time. Although you can, there's at most what, 100 I would say maybe? You're gonna get there eventually, right? And we can actually use a similar technique to determine the types of the columns, right? So the idea is first we have all the nulls, right? So now we know exactly how many columns there are going to be. So if we wanted to detect which one was a string type, right? If we said we defined it as 3, it has 3 columns, we just put in a constant string for one of the columns. And if that succeeds, we know that that is a valid string type. If it doesn't succeed, then we would try maybe a 10 or a constant, maybe integer. And we could move this foo to the other, any of the other ones. So we could try it in all possible places to identify the types of all the columns. Yeah.
Just a brief thought, but I was thinking if the server is is handling exceptions very well, then how do you do that?
Maybe who's working on the blind SQL injection project? Few of you. Yeah, so right, the blind SQL injection, that's exactly what it is about, is how do you do this when you get absolutely no difference between a failed query and a correct query? I think we'll get into this. The idea is you can still do this, right? You can still, and what you do is you add, well, one thing you can do, one typical thing that they do is they'll add a sleep command, like function call, so that way will cause the SQL server a delay in the response from when they sent the query versus when it fails or doesn't fail. That's kind of the standard way to do it. Yeah.
Well, it's also positive, right? Because the query is going to work on the null once you finally hit it. Even if it doesn't give you anything back, you know your original queries.
But the problem is, how do you know the difference between success and failure?
Well, success is when you get that row back.
But he's talking about the case where the web application internally is using that, but it is not externally showing any difference in behavior.
So it's an internal.
Yeah, like it catches the MySQL error and it just keeps going like nothing ever happened, right? So you have no difference between the two, right? That's called the blind because you have no way to tell the success, so you have to develop other tricks to do that.
Yeah.
And it's mainly about changing the execution. But even with that, even if you can tell that one thing, so the trick there is you can change you can use these techniques to kind of figure out, the query and the select, but you actually doing a union doesn't make sense because it never returns the results to you, right? It's blind in that sense too, is where you don't know when it fails, and B, you don't get the results. But using the sleep technique, you get one bit of information which says this was a valid query, or this query's condition was correct. So you can use techniques just using this one bit of information. You can ask questions like, is there a column, let's see, what can you do? You can say things like, is the first table in the database's name, does it start with a letter that's greater than, what's the middle of the alphabet? The middle of the alphabet, let's say T. Is it greater than T? So you can ask that question, and if it is, then you'll sleep. If not, you won't sleep. Right? So that gives you that one bit of information that says, okay, the very first character's name of this table is greater than that. And then you do a binary search to figure out exactly what that character name is. And then you do the second character, and the third character, fourth character, fifth character. Finally, you've got the size of the table, or the name of the table, right? And then you can start asking about columns in that table. Exact same technique, and then you extract data from the table that same way. Yeah, it's really cool. I mean, you can't do it, you gotta do an automated tool to do it, but once you have it, you just keep doing it, and it can extract and download the entire database. Okay. Right, so now we know the size of the things that we know the number of columns that are expected in the select statement, we know the types. Now we need to go, I think Eric made the point about determining the name and the column names. So we're going to use database-specific techniques to extract the names of the tables and the names of the columns, right? So why do these have to be database-specific? Why do we want to know these? Let's go with that. Okay, sorry, new question. This is the original question I want to ask. How do we know what database they're running?
Well, if it's hosted, we may know from just the hosting system, but odds are right now probably MySQL or...
Yeah, so we can guess based on the frequency, right? What other things do we guess? Yeah.
Database error.
Yeah, if we saw any database errors, right? The different database errors are going to give us different strength, right? We can actually, even if it doesn't like tell us the query, we could probably search for the error that it gave, and we would see, oh, this is a MySQL error, or this is a Postgres error, or an Oracle error, right? What else? Yeah.
Every database has its own dialect of SQL, so you can use that dialect to structure your query, and whichever query works, that means using that dialect is the...
Yeah, right. So SQL is like the standard language, but each database system has its own dialect of SQL. It has some functions, like for instance, I believe on MySQL, a hash will do a comment out the end of the line, but that doesn't work in SQLite, I believe. And so you can use those kind of things to basically do detection of what database system is it, right? You're executing queries. You can call what you know is a MySQL function, right? And if it doesn't exist in the other databases, it'll fail. So yeah, there's techniques you use to determine.
A simple scan would also tell you like what kind of service is someone running. So
How did you scan from the outside though?
I mean, you can see like if service is running on port 3306.
Yeah, the port number.
Yeah.
If it is 3306, it will be MySQL.
But how do you know you're outside? You're only talking to the web application, right?
We can get the domain IP, right?
Do you think it would be a wise idea for an organization to allow you to access port 3306
No,
externally?
If we perform a port scan, then you might get the port, right?
Yes, I totally agree. If you have that information, I will say it's highly unlikely. I mean, that's a whole other level of incompetence. Because your MySQL port should not be globally accessible to anyone, right? Then you could see what version they're using and see if there's a remote exploit for that, right? You can do other cool stuff. Yeah, so often you're not going to know from the outside because they won't tell you, right? Normally, In the web context, we assume we have access to port 80, and that's it.
Others are blacklisted, even in AWS, only to the internal machines.
Right, yeah, so that's what we assume kind of is they have this architecture, right, where we can make external requests to port 80. That does some processing somewhere. And then internally, it's making either requests to a database server or the local database on the machine and then returning a result. Yeah?
Cloud services and services like that, the developer has to set up the database usually separately, so that might be a way for the hacker to try and guess their password or something.
Yeah, that's, if it's globally accessible, you have a host of other problems. Yeah, I would just try to brute force your password. I'm sure it's not that good, right? Just try admin, or database. So anyways, once we figure out, we can use these database-specific techniques. So in Oracle, there's a user objects table that we can extract information about table. We can extract the names of columns associated with that table. In MS SQL, there's a sys objects table, which we can do the same thing. And in MySQL, there's information schema.tables and information schema.columns. So using this, it's actually kind of cool, right? Because they allow you access to this information from the SQL language itself. And that is a query that we're building is in SQL. So we can use SQL to query these tables and extract information about them. Okay, we just talked about this. So blind SQL injection, right? Prohibit error message displays. And it's not enough. So the idea is, yeah, as long as we can extract, so I guess there are levels of blind SQL injections. So let's say like this case, we have press releases that we can access. It queries from the database, select title description from press releases where ID is equal to 5, and all error messages are filtered, right? So it doesn't send any error messages. So we can't actually, so here we maybe get a 404 or a page, right? That would be that bit of information that tells us whether the query was actually parsed or not, right? But it's not like we can use this to extract more information like using the union case. But still, so here this would give us, so by injecting 5 and 1 is equal to 1, right? So why 5 and 1 equals 1? Where's my tick?
It's a number. They're directly importing a number instead of a string, so
yes,
you don't have to.
That's the other key thing about SQL injection vulnerability. So oftentimes people only think about single or double quotes, right? And forget that there's a whole, what matters is how is this input being used in the SQL query. Here it's being used here as ID equals this, and the developer chose not to put it in single quotes. And so because of that, if you put a single quote in, you're going to cause an invalid SQL query, right? And so here, this is why I do 5 and 1 is equal to 1, right? Because that just injects in there. There's no additional ticks being happened. And so then this query gets sent to the database. Title description from press releases where ID is 5 and 1 equals 1. Right? And so I'm adding and 1 is equal to 1. Why and instead of or here?
So you would know that ID is a valid ID as well, not just...
Right, I already know 5 is a valid ID, right? If I did or 1 equals to 1, who knows what the application is going to do when it gets back 1,000 press releases, right? It probably is only expecting 1 back, so it could throw an error or something, right? So here I'm saying if it returns the exact same page with 5 and 1 is equal to 1, well then I know that must be a SQL injection vulnerability, right? This is a case of we're using the positive identification technique, right? We're saying if it does this, right? If it was properly escaping things, it would not return the same query, right? It would not return the same press release. It would look for a press release with an ID of 5 space and 1 equals 1, which is clearly not a valid press release, or it's not a valid ID. Okay, so if there's a SQL injection vulnerability, then the same press release should be returned. Otherwise, if the input is validated, right, if it's sanitized, then ID equals 5 and 1 equals 1 should be treated as the value. So the idea is we always know 1 equals to 1 is true, And so we can inject statements. I'm kind of gonna skip over this because we talk about this. So yeah, so we can ask questions from the server, right? We can say 5 and username is equal to hacker, right? So if it returns false, well, it's not really giving me a lot of information. It's telling me that the username is not hacker, which is not great information, right? But if it returns 1, hey, I've guessed the username, right? And so by making complex questions, right, we can do binary search. We can ask interesting questions of the database system to extract bit by bit information from the system. We can say, yeah, so here we'd say ID 5 and substring of username 11, so get the first substring of the username, the first character of the substring. Is it less than, let's say, this ASCII value question mark? And so that would return either true or false. That tells me information about this value. Okay, the other really cool part about SQL injection vulnerabilities, so oftentimes when we think about it when we're testing these things, right, we think, okay, input we get to the application, goes into the database, uses it, used in a SQL query, right, goes into the database means used in a SQL query. So if that happens incorrectly or is not sanitized, then we can have a SQL injection vulnerability, right? So that data directly coming from the user and then going into the database. But what if they properly sanitize the data when it's going into the database, but then later in a subsequent query, they query that data and then use that data unsanitized in a new query, right? Like let's say I wanted to find, like in the course submission system, right? Let's say I wanted to find all users with, let's say, similar names or something, right? Let's say I was safe when I got all your names in, so they could have ticks or whatever, right? But then, let's say I wrote my query as, well, first select all the usernames from the database, then create a new query to select all other users that have the same username, right? And the ID is not your ID, right? So look for people with other similar usernames. Right here, I'm using data from the database that originally came from the user, which is untrusted, unsanitized. It just happened to be I was safe when it was coming in, but the second time I'm using it, it's not safe. So the idea is SQL code or a SQL injection command or attack is injected into the application, but that SQL statement isn't invoked until later in the program when the application uses that data. And it could be, it could be when it could be anything when a cron job runs, like on a guest book page or a statistics page or anything like that, right? So you could have a guest book where guests write comments, and then a statistics page that kind of shows how many people are writing comments. So the idea is, right, because when you escape single quotes by putting the data into the application, you still have single quotes in data in the database. Right? So when the database pulls that data out and uses it, it came from the user, it's untrusted. So the attacker can set their username to something like John Tick -- right? So the application, when it inputs it into the database, right, safely escapes that tick by putting a slash there. But at a later point, the user changes their password and the query uses that username from the database. So it says update user set password equal to whatever, where username is equal to John -- right? So now I've changed John's password, even though my name was John Tick. Right? So I could make a name of admin tick -- right? To be able to change the admin's password and then be able to log in as admin. Let's look at an example. So here's a register page. So here we're starting a session in PHP. We have the SQL query of insert into users, username, password, values, name, and password, right? And we're using the MySQL real escape strings functions, which is how you do validation and encoding with MySQL and PHP, right? So we do this query, we check, and then we set it into the session, right? So here we're properly building the query, right? This is 100% safe. There's no way they can change our query that we intended on the MySQL query, right? There's no way they can change that SQL variable. But now on the change password page, let's say now I have a new password and I select the username and password from users where ID is the session ID, right? And the session ID was set, so A, it's stored on the server so the user can't control it. B, it is just an integer, so it's gonna be safe. So we did not call MySQL escape string here, right? But we know it should be safe because the user should never touch it, but maybe we should probably add that here just to be extra sure, just in case. So then I fetch this result from the database, right? So I do this initial query, right? I make this query, I get the result back, and then I query to update the user set password equal to MySQL real escape string new password, right? And here I'm being really careful. This new password came directly from the user, right? I need to escape it before I put it into the database. But I just got this username back from the database, so what's the problem with inserting it directly in here? And then I issue this query, right? So the key about second order SQL injection vulnerabilities, and it could be n order, right? It could be n number of steps where it's used and put into some other database or put into another table or something, right? But the core idea here is that just sanitizing things as they come in is not always enough, right? That data could still be, we like to think about it as tainted, right? Anything that comes from the user is evil, bad, tainted, until we make it good by calling this MySQL real escape string, right? So we make it good to insert once, right? But if we ever use that data again, it's still tainted. It still came from the user. Okay, so how do we solve SQL injection vulnerabilities?
Parameterized queries.
Parameterized queries. What are parameterized queries?
So you have like placeholders for like all the variables.
Yeah, so really fundamentally, right, our goal as developers, in order to never allow SQL injection vulnerabilities, we cannot let client-side data, right, data that comes from the user, to modify SQL statements, right? This is the core SQL injection vulnerability problem, right? One way to do that is by using stored procedures, right? So stored procedures are a way to isolate the applications from SQL. They actually are a way that you tell the SQL server, hey, or actually, sorry, yeah, stored procedures. Wait, why am I? Okay, yeah. Sorry, getting confused between stored procedures and prepared statements. So what was the one you said?
Parameterized queries.
Parameterized queries, yeah, like prepared statements.
Yeah.
Okay, so stored procedures, right? Some databases you can put functions into SQL, and then you can just call those functions from your application, right? So this way, all the SQL statements that are required by your application doesn't build up SQL queries. It uses the functions that are defined in the database. Prepared statements, the idea of prepared statements is your application tells the database, hey, I'm about to make a query, and here are the placeholders of where I'm going to put data. And then the SQL server pre-processes and parses that query and says, okay, great, let me know when you have the data. And then you say, hey, here's the data. The first parameter is this, the second parameter is this. And so the idea is that the statements are compiled and parsed before the user input is added. So you're separating this process. And so really prepared statements are basically the way to go. This is the only way to absolutely ensure that you have no SQL injection vulnerabilities. Because you're providing the structure of the query first, and then you're providing the arguments. So those arguments cannot change the structure of the query, right? The SQL server has already parsed it. It already knows exactly what it should be. So an example of this in PHP. So here I'm selecting all from users where username is equal to :name. So this is just a placeholder. And password is equal to SHA-1 concatenate password with salt limit 1, right? So now I'm preparing this statement. So the :name and the :pass, right? These are just placeholders that tell the SQL engine, hey, I'm going to give you the values of name and pass, and here's where I want you to use them. But parse this thing now, right? Get the structure of this query now. And then bind name to :name, bind pass to :pass, and then execute the query, right? Now there's no possible way that name and password can ever alter the structure of this query. So what's the difference between this and the other way? Yeah.
The name and the password in the other way, the name and the password are treated as SQL statements, but here they're not.
Yes, but from a programming perspective, which is easier?
The other way.
Yeah, the other way, right? And you can see that's why that's what developers go to, right? I mean, you can do it in one line, right? You can do MySQL query string with embedded, $name, $pass, right? And it's exactly what you mean. That's what you wanted. You want the query with the data represented here. But here you have to do what used to take one statement, 4 statements, right? You have to prepare it, you have to bind, and then you have to execute, right? But this is the way you have to do it in order to be 100% sure. The other way you have to do it is you have to make sure absolutely anything that touches a SQL query has to be sanitized, right? But that's actually a much harder task than doing prepared statements, right? This is fundamentally correct. This is kind of just a workaround and a Band-Aid. You're like, well, I don't really want to use the proper way to do it, right? Because think about it. Let's say that we do use the MySQL real escape string, right? But we're using it without being surrounded by single quotes, like in that user ID example. The press release example, right? Here, even if, where's the thing? There you go. Select title description for press release where ID equals, right? We have no ticks around here. So even if we real escape this, we can add spaces and we can add and we can add space and we can add 1 equals 1. Right? We just can't add single quotes or double quotes or some other characters. We could still have a SQL injection vulnerability here, even though it looks like it is correct and that you properly sanitized everything. It's because you did not use the single quotes to capture the input. This problem will not exist using prepared statements. And that's why prepared statements are a better way to go. Right, so let's stop here and we will talk about cross-site scripting vulnerabilities on